All right, this is our last example for exploring graphs of rational functions. You can type in any rational function you want into Desmos and you can take a look at it and explore it. We can graph it obviously without Desmos, but we're going to use Desmos next classes to make sure we are graphing it correctly. But eventually you have to be able to graph it without a graphing calculator or graphing tool. So let's start with the restrictions. X cannot be 2. Because if the denominator was 2, then if x was 2, then the denominator would be 0. So I know that x can't be 2. So I know the domain is from -2, or from negative infinity to 2, skips over 2, and then goes on to positive infinity. Before I decide if this is a vertical asymptote or a hole, I need to factor the numerator. And the numerator does factor to x minus 2, x plus 1. And then the denominator is x minus 2. Well, here we have a special thing that has happened. The numerator and denominator have a common factor of x minus 2, so they factor out or cancel out. So that means that the restriction x equals 2 is not a vertical asymptote. It's actually just a hole in the graph. So the graph will continue till x is 2, and then it'll skip over it. It'll look something like that. So it doesn't have a vertical or a vertical asymptote. It has just a hole. If we calculate the zeros are simply the solution to the numerator, and that would be x equals -1. Because if you set the function equal to 0, you cross multiply, your x minus 2's are going to, you would get x plus 1 equals 0, and x would equal -1. So the x-intercept is -1. X equals -1 right here. And also you'll notice that when you simplify, the function is actually a line, x plus 1. It's very simple. So it doesn't really have a horizontal it definitely doesn't have a horizontal asymptote. And it doesn't have a slant asymptote, it simply has a basic hole. And the y-intercept of this is 1, 0, 1. I actually prefer to just write the intercepts using an ordered pair so you don't think it's an equation of a line. So the y-intercept is 1, and that makes sense because the equation of the line is y equals x plus 1. So the equation looks like this. It's funny how the rational function actually winds up looking like a line. But the difference is there is a hole at x is 2. So if I go over to 2 and up to the function, there's a hole here. The function actually skips over that value. It continues, it gets to 2, it jumps over it, and it continues on. So that's what's different about it from being a line. So let's check that out on Desmos. So here I wrote in the original function, and it looks just like the one we graphed after we simplified. But I want to scroll over 2. Gets up to 2, and then notice what happens when I get to 2. Undefined. So sometimes it's hard to see when things are undefined, but you have to be able to identify when the function is undefined because it gets so close to 2 that on a graph with the naked eye you wouldn't be able to see that. It skipped over the actual number of 2. All right, so this should be done. We're going to talk about this next class, and you guys have functions that you're going to explore more of, and you're going to actually be presenting one as part of your grade. Good times. So let me know if you have any questions and submit this so I know that is done prior to class. Thank you.